Hey there, CS210 students. So in this recording, we're going to go through Chapter 8 here, and in Chapter 8, we're going to talk about exceptions and how to properly handle them. So hopefully in your Java class, they might have had some exception handling in there. If not, I'm going to guess at this point in your programming career, you've definitely encountered exceptions where you ran your code and while it was running, something bad happened, and in the console you got a whole stack trace showing all the issues that were all the issue and then all of the lines of code that were affected by it. So an exception occurs when something in the program violates the programming environment that you're in. So a really good example of an exception that's commonly done is you try to divide by 0. Okay, so mathematically you can't divide by 0. So if you try to divide by 0 in most programming environments, it's going to crap out. Another thing that's commonly done is a null pointer exception, where you have not initialized a variable. You try to use some method that's associated with the object, and the object hasn't been initialized, so you get a null pointer exception. So I'm sure you've run into some of those along the way. So today in C++, we're going to learn how to handle exceptions in C++. So first thing here, we've got some code that is going to calculate a BMI, so a body mass index. And then this example here, we don't have any error checking at all. So we ask the user to get in a weight, we ask for their height, and then we come down here and we calculate their BMI. Well, you can see here, what if they enter in the weight as a negative number? So it doesn't make any sense for this to be a negative number. So then you're going to get some kind of weird result for the BMI calculation. So heights, weights here, those should be positive numbers. So we'll go a step further. We will add in a if statement. So we can check if the weight's less than 0. We can check if the height is less than 0. And really, ideally in this situation, this should be a loop. So this should be while weight val is less than 0. We displayed the message. We get we prompt them again. So really, in the big scheme of things, we would handle this using a loop to validate the input, but they're using this to demonstrate exceptions here in a second. So this is all copacetic. So this would be if you're using if statements to check and validate things. They also provide then a way to use a try-catch block. So in programming, every language has some kind of try, and then there's a block of code. So this is the code that we want to try to do. And if an exception happens, so if something bad, something were to potentially crash the application, we would jump down to a catch block, assuming that we catch the correct type of exception. So down here in the catch block, we would print an error message, do whatever we need to do. We would, again, let the user know that something bad happened in the program. So in the improved BMI calculator, they've got a try. So here's the open curly, there's the closed curly, and they're going to catch what's called a runtime error. So in order to use this construct, we need to include the standard library, standard exception library here. So what we're going to do is we're going to try and we're going to get in the weights. Here you can see where they put a check. So if the weight val was less than 0, they're going to throw an error, a runtime error, specifying that it's invalid weight. So if that's the case, when we throw this error, we don't continue on. We would jump down to this runtime error block down here. So the exception has a what field. We can grab it, display out what exception happened, and we can just simply also say cannot compute the health info. Now they're doing that here. I'm not a big fan of this, so if this were to get sent to me on the project that I'm running, I'd be like, no, you're not wrapping everything in a try block. You're not going to throw a runtime error when this is less than 0. Again, ideally this should be controlled in a while loop to make sure that you get the proper input. Okay, we only want to throw exceptions when we as the programmer have no other option. And we'll see another example here in a second of where it would be better to throw the exception. But hopefully what I want you to understand here is we have a try block. If something were to either we threw the exception or if the exception happened because of some improper handling by us, then we would be in the catch block. And again, we handle the catch block. We can't perform any calculations here. So, this is just going to display the error message, and that's fine for now. Okay. So scrolling down, they do mention some common exception types. So we saw up there that they were catching the runtime error. Basically, that's going to catch just about anything that is detected at runtime. So you could have overflow errors, arithmetic overflow. I'm assuming, in fact, here, let's just go see what C++.com has here. So this is runtime error. So lots of things are going to extend from runtime errors. So it could be range errors, overflows, underflows, system errors. So lots of different things are going to encompass the runtime error. We could throw our own logic errors. So, if we check that our index is out of bounds, we have a range of 1 to 10 and, we try to use index 11, we could throw a logic error. And then this is one that you'll be using for the lab, is the input-output stream base failure. And you have a failure in a stream. So for instance, CNing using string stream or F stream. So any kind of stream exception can get caught using this right here. And oh, by the way, this would be very useful that if you're expecting to see in some data to an integer or a string and it doesn't happen properly, then you could then use this exception handler right here. Okay, so we can also have exceptions in our functions. Again, you can have exceptions anywhere. They, again, showed it in the main method to start with, but we could have had a method that does something like this, where we ask the user for the weight, we see in the value, and if the weight is less than 0, then we throw a runtime error. So this would crap out if it's negative. Get height, same deal. If this is negative, this is going to error out. And so you can see now here, we know that the get weight, get height methods, these potentially throw exceptions. So this needs to be encompassed in a try catch block here. Oh, by the way, the documentation for this, keep in mind, our documentation will look something like this. Get the weight from the user, and then at raises, this is throwing a runtime error. So it raises runtime error when weight is negative. So just like we've seen with the parameter values, if we have any, this should have a return statement. So we need to also document in our method any exceptions. So that way, when I hover over it in IntelliSense, I can see, oh, hey, yeah, this raises an exception that I need to handle myself, okay? In other programming languages like Java, I have to specify in the method definition that it throws an exception, but that is not the case here. So here, I would have to, in my documentation, include that comment, okay? All right, so section 8.3, we can have multiple catch handlers. So we could have a try, and then some kind of exception could get thrown along the way of type 1, type 2, type 3, whatever. And then we could have exceptions that get caught in the order in which we want to handle them. So keep in mind, if you go back to section 8.1, I know this is a little bit beyond the scope of our knowledge right now because we haven't talked about inheritance yet, but if I just try, come back here. I clicked the wrong link. I want this one. So runtime error is going to catch all of these types right here. But if I wanted to specifically handle range, overflow, underflow, if I wanted to handle these specifically with specific messages and so forth, a good way to do it is to have a catch block with each specific type, and then I can properly handle each different type, okay? Um, oh, by the way, I'm not a big fan of wrapping absolutely everything in a try catch block. Uh, only wrap the try around things that you know are going to throw exceptions, okay? All right, so for the lab in this chapter, here's what you need to do. So we have input that's going to be a string followed by an integer. So we have a name with a age value. What we want to do is we want to read in single word first names and ages. So right here is the bad case. This should throw an exception because our code, for whatever reason right now, we're not going to implement a name like Mary Beth. So we would want to handle this with an exception getting thrown, but everything else should be handled properly. And again, -1 is our exit out. So they give you the code right here that you need to start. So what you need to do is you need to get rid of that fix me. Remember, leaving to-dos, fix me's not allowed. So get rid of that. But we do need to put a try right here, encompass this code in a catch block that catches this type of exception right here. Okay, so use the exception, and they want us to then output just the first name that we read in, and then we'd output a 0 when it has the exception. Okay, so that will be handled in your exception block. So not too difficult. I think you should be okay with that. All right, so that is the short recording on the exceptions.